Welcome back. So we continue with solving problems 0.7. Problems 0.7. We continue with our solving equations. Okay, so look at number 77. 77 says we should solve for y in this radical equation. Solving for y in this radical equation. Okay, so in this radical equation, so looking at this, okay, before we do 77, I would like us to do a much more trivial radical equation before we move to 77. Look at number 69, for instance. 69 says we should solve for x in the radical equation square root 2x plus 3 equals minus 4 equals 0. Okay, so as I said, if we only have one radical in our equation, what you need to do is just to isolate that radical, then raise both sides to the power of the index. But if you have two radicals, you need to isolate each of them. So one of them should be on one side of the equation and the other on the other side of the equation before you raise both sides to the power of the index. Okay, to make it easier for you to eliminate the radical sign and be able to solve the resultant linear equation. So isolating this radical, we move 4 to the other side by adding 4 on both sides. By adding 4 on both sides, all right? It becomes a square root 2x plus 3 equals to 4. Then the index here is 2 because it's square root, so we square both sides of our equation. Square and square root cancel each other. 2x plus 3 becomes 16. Okay, so we then have this resulting linear equation to solve for x. We move 3 to the side by subtracting it on both sides. Subtract 3 on both sides to move 3. 2x plus 3 minus 3 equals 16 minus 3. 2x equals to 13. Divide both sides by 2 to get x equals 13 over 2. Okay, that's that. Now let's look at number, where was number, that was number 77 that we wanted to look at. Number 77 says that 77 square root of y plus square root of y plus 2 is equal to 3, and we have to solve for y in here. Now, common mistake will be to square both sides like this, okay? Now, this, you may end up getting the answer, but it will take you a much longer time to eliminate your radicals in this manner than if you isolate these radicals and then before you square both sides, okay? So isolating these radicals means moving one to the other side so that only one radical will be on each side of the equation, basically, okay? Only one radical should be on each side of the equation. And then you go ahead and square both sides. Again, I made a comment when we were doing our first video on solving equations that while squaring both sides, I have had students in past years make the mistake of squaring in this manner. This is wrong because mathematically a squared plus b squared is totally different from a plus b all squared. All right, squaring both sides simply means put everything on that side in one bracket and under one square. Everything, okay, not separately. So all of this squared like this. Take note of the difference between the two. So once you have this, your square and your square root sign cancel, and we only have y on this side is equal to 3 minus square root of y plus 2 times 3 plus minus, sorry, square root of y plus 2, okay? So that's actually what the square of that means. That square actually means multiply that quantity by itself, basically. That's what it means. Okay, so if we then open up that bracket, we get 3 times 3 is 9. 3 times minus square root of y plus 2 is minus 3 square root of y plus 2. Minus square root of y plus 2 times 3 is minus 3 root y plus 2. And minus root y plus 2 times itself will be positive y plus 2 because the square roots do cancel, okay? So I showed you how this cancellation happens. I showed you that, quickly, let me show it again. Square root minus square root of y plus 2 times minus square root of y plus 2 by our laws of exponents will be minus y plus 2 to the half times minus y plus 2 to the half as well. Minus times minus is a plus. Y plus 2 to the half times y plus 2 to the half. They have the same basis. So law 1 of exponents permits us to simplify this by adding their powers. So it becomes y plus 2 to the half plus half, which is y plus 2 to the 1, which is just y plus 2. All right. So that's how my square root of y plus 2 times square root of y plus 2 becomes y plus 2, basically. So it's by the laws of exponents, by the law 1 of exponents. That's how I got that. Okay, so that said, we can then collect like terms. So y becomes equal to 9 plus 2 is 11. Minus 3 root y plus 2 minus 3 root y plus 2 is minus 6 root y plus 2. Okay, so see root y plus 2 as a variable. Maybe let's say minus 3 bananas minus 3 bananas becomes minus 6 bananas, basically. Okay, plus y. Okay, so what we want to do now is we still have this radical equation, okay? Our goal is to eliminate all the radicals and end up with a linear equation to solve for x. So we still have this radical in our thing. We isolate it again and square both sides. We keep isolating the radicals and squaring both sides until we no longer have any radical in our equation. Okay, so we do that by moving the y to this side and the 11 to this side. So if y and 11 come this side, it becomes y minus 11 minus y equals minus 6 root y plus 2, basically. Y minus y disappear. We are left with negative 11 equals negative 6 root y plus 2. Squaring both sides, we get 121 equals to 36 times y plus 2. Okay, and we can then solve that linear equation. 121 equals 36, y plus 2 is then a linear equation which is easy to solve for y. All our radicals are now gone. All right, so I can divide both sides first by 36. This cancels. 121 over 36 is equal to y plus 2. Then we isolate y by subtracting 2 on both sides. It becomes 121 over 36 minus 2 equals y. You can then simplify that using your calculator to get that answer for your y. Okay, so that's how to solve the radical equations. Basically, let's take another radical equation example. Okay, this example says square root. So this is number 80, square root 1 over w minus square root 2 over 5w minus 2 equals 0. So notice that this is a combination of fractional and radical, okay? Because we have radicals there, but the radicands are fractions, fractional expressions, okay? Radicands are fractional expressions. So how do we go about this? We see that the fractions are in the radical signs. So we start by first eliminating our radicals. Then we expose the fractional equation that we solve using the method for solving fractional equations that we have seen. How do we go about this? First things first, isolate the radicals. There should be only one radical on each side of your equation for you to be able to remove the radical sign. So if I move this guy to the side by adding it on both sides, I then end up with something that looks like this. Okay, adding it on both sides. Now I am ready to square both sides so that my radicals can disappear. My radicals can go away. 1 over w is then equal to 2 over 5w minus 2. Okay, so this is then a fractional equation that I want to solve for w. Again, with only one fraction on each side of your equation, you can do your cross multiplication. Okay, so that 5w minus 2 equals 2w. 1 times 5w minus 2 is 5w minus 2. W times 2 is 2w. All right, and we want to solve for w there. So we move this 2w to the side to join the 5w. We get 5w minus 2 minus 2w equals 2w minus 2w. Right? We move it by subtracting w on both sides. So 3w minus 2 equals 0. We move the 2 to the side by adding 2 on both sides since 2 is being subtracted here. 3w equals to 2. Divide both sides by 3 to get your w equals 2 over 3. That's the final answer for that particular fractional equation. Okay, now let's look at a couple of literal equations, solving literal equations. As I said, literal equations are simply equations in which constants are represented by letters, but usually one of the letters will be the variable, and then all the others will be treated as constants. Okay, look at number 82. Number 82 says we should solve for p in the equation p times 1 plus p over 100 minus, okay, p times 1 plus p over 100 minus r equals to 0. Okay, solve for p in this equation. Solve for p in this equation. Okay, so we want to solve for p, so we isolate p. Simple. We move everything else. So looking at this equation, we move everything else to the other side and leave p alone on one side. Okay, so I would like us to start by multiplying in this p. Okay, so it becomes a p. I'm just hoping it won't give us a quadratic. It may. Okay, it's giving us a quadratic, which is not really what I want because we are yet to do quadratic equations. So I would like us to leave this number 82 until when we do quadratic equations, and go to do maybe number 86. Okay, 86 says we should solve for I in R equals 2mi over b times n plus 1. Okay, and we are solving for I. Solve I. Okay, we are solving for I here. So you can see that the literal equations constants are represented. If we are solving for I, it means I is our only variable. M, R, B, and N are all equally constants. All right. So to solve for I, first things first, we can isolate I by removing this denominator. All right. Moving this quantity to the other side. So we can do that by multiplying both sides by 8 equals 2mi over b plus n, b times n plus 1 times b n plus 1. So this guy cancels with this guy. Rb plus 1 equals 2mi. All right. 2m is being multiplied here. We can remove it from this side by dividing it on both sides. Cancels, and we are left with I alone on this side. So it means our I is Rbn plus 1 over 2m basically. Okay. So with literal equations, the solution is usually in terms of those other constants that are represented by letters. The solution is usually in terms of them. Okay, look at number 88. 88 says we should solve for R in R times 1 plus or 1 minus R times number 88, 1 plus I to the n, 1 plus I to the n minus 1 O over I. Okay, and we are solving for R here equals S. We are solving for R, all right? So the first thing, we want to isolate R, therefore solving for something means isolating it, moving everything else to the other side and leaving that particular variable on one side. So if we multiply both sides by I, first of all, okay, if first of all we multiply both sides by I, we get, we multiply both sides by I, we get R times 1 plus I to the n minus 1 over I times I equals S times I. I cancels with I, R times 1 plus I to the n minus 1 equals to Si. We then divide both sides by this quantity, 1 plus I to the n minus 1, divided by 1 plus I to the n minus 1. This cancels with this, and we are left with R equals Si over 1 plus I to the n minus 1. Okay, so that's how literal equations are solved basically. Okay, look at this other literal equation, which is actually a literal, but a fractional literal. Number 90, x minus a over b minus x equals x minus b over a minus x. And we are solving for x in this fractional literal. Okay, to solve for x in here, we have exactly one equation on each side, exactly one fraction, sorry, on each side of our equation, so we can cross multiply. We have x minus a times a minus x equals x minus b times b minus x. Open up our brackets, x times a is ax, x times minus x is minus x squared. Negative a times a is negative a squared. Negative a times negative x is positive ax is equal to x times b is xb, x times negative x is negative x squared. Negative b times b is negative b squared. Negative b times negative x is positive bx. Okay, we collect like terms by moving all of these terms to the side to add up with the like terms on the side. So we have ax minus x squared minus a squared plus ax. Bring these guys to the side. So this guy is being added, so we subtract it. Minus xb. This guy is being subtracted, so we add it. Plus x squared. This is being subtracted, so plus b squared. This is being added, so minus bx equals 0. Okay, so this is done. We then look at like terms. So ax plus ax is 2ax. Okay, the guys are gone. Negative x squared plus x squared is 0. X squareds disappear. We have a minus a squared there. Then we have x minus xb minus bx is minus 2bx. And a plus b squared there equals 0. So we want to collect the terms in x together. These are the two terms in x. So if we factor out x from these two terms, first of all, we move the constants to that side, right? If we move our constants to the other side, we get 2ax minus 2bx is equal to a squared minus b squared, okay? A squared is being subtracted, so it comes to this side to become added. And b squared is being added, so we subtract it on the side. Okay, if we factor out x from these two terms, we then get x into 2a minus 2b, greatest common factor. All right, don't forget your methods of factoring. Then x, this quantity is being multiplied to the x, so we can divide it on both sides to actually eliminate it from that side. This cancels, and our x is a squared minus b squared over 2a minus 2b. Okay, so practically these are equations, solving equations, and this has then brought us to the end of